an empty script. Go here, new plus sign, and from the drop down arrow select script. So this would open a blank script or empty script. And then please save this script, go to save and then save as. Sorry. Where can I save this file? Or maybe in the desktop. Let's get a new folder. And save this file as read pro. So this would be our code for river profile analysis, and you give an acronym read pro. Read pro. Done? Yes. Please save this file in your MATLAB underscore course folder. Okay. Name of the file is read pro. Okay. So I hope all of you have downloaded the MATLAB course, right? There are a couple of courses. One is under a folder named Topo Toolbox. So please save everything in MATLAB underscore course folder. Okay? Save all files that you downloaded from Google Classroom. All MATLAB files that you downloaded from Google Classroom should be stored in the new folder named MATLAB underscore course. Okay. So what is Topo Toolbox? So this is the collection of MATLAB functions, okay, for hydrological and topographical analysis. Okay, the analysis that you perform using GRS. Okay, the same thing is implemented in MATLAB. Okay. Now this repro would be our wrapper file, a wrapper function. What is this? We will use this function to call the function in Topo Toolbox. Okay. And remember, when you are coding anything, always you have to write the comment, okay, so that you can remember, okay, that what you intend to perform. Okay. For every line that you write in your MATLAB code, beside it you should have a comment. Okay. So let's first write. So we write comment using this percentage sign. Okay. Comment means MATLAB won't consider it for any calculation of okay. Using percentage sign, could be single percentage or double percentage, right? Script for river profile analysis. Then written on 2024. So at the preamble of any math script, okay, we always write this three syntax. Okay, close all, clear hash, CLC. Close all means if you have any open MATLAB window, this will first close everything. Clear hash means if you already have some variable loaded in the MATLAB, it will clear and erase. So it will erase the memory. Okay, and CLC, that means if you have anything written in the command window below, that is also erase and clear. Okay, right. So this should be all in all of your MATLAB script. Okay, whenever you write any MATLAB script, this should be by default. Right. And then if you want to access or call any functions, okay, which is stored somewhere in a directory, okay, then you have to add that folder to MATLAB first. Okay? That means there has to be a connection between that folder and the MATLAB so that MATLAB can access any function available in that folder. Okay. So to do that, we use the syntax add path. Then change path, and then copy the folder directory and copy the path of your folder, okay? And which folder? Where you have all the Topo toolbox. So this should be the path of your Topo toolbox folder. So Swagat, where is your Topo toolbox? Here. So go to Topo toolbox and then copy the path location. And then paste here. So the path location should be within single colon. Okay. So apart from Topo toolbox, you have two more MATLAB functions, right? So within MATLAB underscore codes folder, create a new folder. Go to your MATLAB underscore codes folder and create a new folder and name it TAK. TAK. So this is acronym for topographic analysis kit. TAK should be in capital. Capital T, capital A, capital K. Okay? And copy and paste those to MATLAB code within this TAK folder. So what is the full name of TAK? Topographic analysis kit. So please copy those two MATLAB function within the TAK folder. Okay? Done, Prakash? That means in MATLAB underscore course folder, you should have two folders, okay? Topo toolbox and TAK. Show me your folder structure. Okay. Yes, yes. Repro should be outside of TAK. Okay. Then please add the path location of TAK folder. Done. So right here comment add topo toolbox to MATLAB search bar. Okay, then next we'll now import the DM in MATLAB. Okay, so write comment here import DM to MATLAB using the grid object function. So this grid object function is available in Topo Toolbox. Okay, so using this grid object function, we will import the DM to MATLAB. Okay. Now, write first the path of your DM folder. Copy the DM folder path. And then at the end of your path, you should have a backslash. Then create a new variable named DL.
We use the unzip folder. Don't give the path of the zip.
Unzip. Okay, then create a new variable named DM. Okay, so here we'll create a DM variable by importing the DM from this folder DM path. Okay, so what is this variable DM? This should be our DM raster. Okay, we'll now import this raster in MATLAB. Okay, how will import? We'll import by calling a function named grid object. Okay, this function is available in Topo Toolbox. Okay, so how to call a function? First, you have to write the name of that function, and then you have to provide the input. Okay, this is same in all programming language. Okay, so name of this function. So the function name should be exactly the same as written in the function header. Okay. So to check that, please go to Topo Toolbox folder and then go to add grid object folder, and towards the bottom of this folder you will find this grid object function. Look, go to Topo Toolbox, then at the rate grid object, and then towards the bottom you go and find this function grid object. Okay, do you all see this grid object function? Yes. Check how it is written: grid in capital and obj in small. So when you call the function, it has to be exactly the same. Okay, grid object, which should be within the parenthesis. Okay. Now to call the DM, so first you have to provide the path, means where this file is stored. Okay, so this should be within the third bracket. Okay, DM path, and then within quotes the name of your DM file. So what is the name of your DM file? srtm underscore utm 43n.p. srtm okay, let's wait.
TIF. TIF factors. 53.
Sir, can you please connect the projector? Download it. Wait. Okay. Okay. So now to check if you have any bug in your code, you can run it. Okay. So to run, you can use this green arrow, or you can just hit F5 in your laptop. Do you find any bug in your script? Yes. Yes, you have to change the folder. What is this? Okay. Oh, you don't have the toolbox. Okay, check your folder path. So once you return to your room, you install MATLAB. I mean, don't. Yes, yes. Hmm? Here that read obj is command that uses read object to call the DM. Yes. Read object. Actually, there is a change. Ah, it's 43. Okay. Oh, check the DM file name SRTS underscore 43L. That is why we are all getting the same error. Okay, now it should work. स्वागत वाटर पे नीचे तो image SCH. Yes. You get any bugs? Okay. Now to check if your DM has successfully imported in MATLAB, you can just plot the data. Okay, right? In your command window, image SIMAGE image HC, then within parentheses, write the name of this variable DM, and then hit enter. Image HC. Okay, you will find the DM. Okay. So if many of you I don't think have the image processing toolbox, so some of you might get error here. Image HC, S small c within parenthesis, variable name, DA.
Please keep all the paths under single quotation. Double quotation will show you error.
Now, if you want to visualize the 3D topography, then instead of image HC, you write this command image SCHS. HS, image SCHS, DM, DM. So you have to write the variable name twice within parentheses. Then you will see the color coded 3D topography. Shankhadev, what happened?
I got some problems.
Sir, is it third bracket or second bracket? First bracket?
Yes. When you call any functions, variable input variable should be in first bracket, within first bracket. Okay.
Want to go back, you can do not delete MATLAB, but just go for reinstalling from network account. They will have the option for adding this. Don't uninstall MATLAB, but you can.
So our institute provide license for all toolbox available in MATLAB. Okay. So when you install, you have to select everything. Okay.
Image
Image
processing.
statistical toolbox, image analysis toolbox, everything. Those who doesn't have image analysis toolbox installed, you will get the error.
I want this one, but not that.
Yes, because that requires the image processing and statistical toolbox together. Image HC, that would only plot the DM. Okay, but SCHS, that would give you the hill set topography. You remember you have done in our 30% of the PD. Yes. So at the back you have hill set, on top you have DM with 30% transparency. What happened, Shankhadev?
No. I don't have the image SCH toolbox. Something
Ah,
like
okay, so you have to uninstall and then again install MATLAB, and please make sure when you install, you select everything. Okay? No, it would take long time. Okay. Please do it later. Just write down the wrapper script. Okay. Who has the problem with image processing toolbox? All of you have the problem.
Okay, whenever you give equal to symbol, you have to close it with a semicolon like sir has shown.
Yes.
So please make sure.
Why the semicolon? This is to suppress the print. Okay. Otherwise, it would be print in your command window. Okay. So to suppress this print, we always use this semicolon. Same in all programming language. Okay, now please look at me. Now we have to define a threshold drainage area where a channel would initiate, okay, or start to flow. For example, this is a drainage basin. Okay. Now this is the point where you have the first initiation of channel, and then as you go downstream, the channel grow longer. Okay. So the point where the channel starts, okay, that is set at a threshold drainage area. That means what is the requirement to form a channel? You have to accumulate the water. Okay. And now to accumulate sufficient quantity or sufficient volume of water to further flow, you need a minimum drainage area. Okay. Because the volume of water that would flow into a river, that is set by area as well as how much rainfall on the landscape. Okay. So that area where we have the initiation of first channel, we call SE, that is the threshold drainage area. Okay. So we have to define a threshold drainage area where our channel would start. Okay. So in most natural landscape has been observed that this threshold drainage area lies at an area of 1 square kilometer. Okay. So from our observations from natural landscape, we found that this threshold drainage area is 1 square kilometer. That means when you have an upstream area of 1 square kilometer, then you have the initiation of a real channel. Okay. So now we'll define this threshold drainage area for channel initiation. Define, so write in the command, define threshold drainage area for channel initiation. Then we create a variable named crita. Crita means critical area. Okay, and we write here the value 1 E6. That is drainage area of channel A in square meter. Now, do you recall in your RGIS what was the first step? You feel the noise present in your DM, okay? Followed by we generated the flow direction raster. The same thing we'll do here, okay? So now we'll create a flow direction raster, okay? By filling the hole first, okay? So write the command window, generate a raster of flow direction from each cell to its down sloping neighbors using the algorithm. Generate a raster of flow direction from each cell to its downsloping neighbors using D8 algorithm. Then create a new variable name FD, which stands for flow direction, and then we have to call the flow object function from Topo toolbox. Okay. So the name of the function is written first in capital letter. The flow should be in capital and object in small. Okay. What are the input for this function first? The DM. Okay. Followed by you have to define. You have to fill the hole. Okay, using this pre-process
Silent हो रहा
function. So within this function, the hole filling and flow directions, they are incorporated together. Then let's run if our code is okay. Sorry, carve. Should be CARVE, not U. Carve. Okay. If you get no bug, that means your code is okay. Carve means just fill the hole present in the DM. Okay, so this process we call carving, filling the hole. Okay, or removing the noise from the DM. Okay. Pre-processing means prior to flow direction, we carve the DM. Okay, that is why it's called pre-process. As I said, within this flow object function, DM processing and flow directions, they are incorporated together. Okay? But before it calculates flow direction, it first removes the noise. Okay, so that's why we call it pre-process. Okay. Now run your script, check if you find any bug. Okay, that means your code is fine. Now do you recall what's next? We have to calculate the flow accumulation raster. Okay. Calculate accumulated flow. Create a new variable named A flow SEC. And then again run. At every step you should run your script to check if you have any bug.
Flow object to process.
Now what next? Huh? Yes. DFT process call. you are getting this word because you don't have image processing toolbox. Okay. So what's next after flow accumulation? Somebody, we have to extract the stream network. So right, comment extract stream network. Okay, now listen. So we said that we filter the stream by defining a threshold area. Now our stream is in the form of accumulated flow, right? But we define the area, a threshold in area. That means we have to convert the threshold area to flow accumulation value. Okay. So how we do that? We have to divide the area, threshold area AC by the area of each cell. Then you get number of flow accumulation. Okay. So we convert area to flow accumulations, number of accumulations. Okay. Now to convert this, we need to know the cell size. Okay. So if you are not sure what is the cell size, you can easily get by writing dm dot cell size. Okay. This will provide you dm cell size. Now we will extract stream from the flow accumulation raster, the way we have done in ArcGIS. Okay. So the functions that we use here is stream object. Stream object. Stream should be in capital and OBG should be in small letter. And what is the input to this function? The flow direction raster that you calculated in previous steps. And then you have to define the threshold in terms of number of accumulations. Okay, so we provide mean area be the now you can run to check bars. If you find no bar, then you can plot the stream network using plot as command. Okay? We want to plot the stream network. Okay? Write plot and then within parentheses S, the stream network.
you all are lacking the mapping toolbox also.
But some of you have mapping toolbox, right? Somebody has.
So this flow update won't show unless you have.
Yes, if you don't have mapping and statistical analysis tool, then it won't work.
So this is a MATLAB Lab.
Sir, what is mean area?
Just now I explained there in the board. Where was your mind?
I was seeing,
Huh?
I was seeing that, but area of accumulation.
Please take a note of all the
What we have done here, we define a threshold area. Okay. Using this mean area command. What lies next to it? The threshold value. Okay. So initially we provided the threshold value in area, square meter. Okay. That we converted here to number of accumulated cells. Okay. So critical area divided by area of one cell. Okay. So that would provide the minimum area in terms of number of accumulated cells. Okay.
So the formula that critical area divided by the
Area of each cell.
that you are defining it as minimum area.
Minimum area. Where our channel would stop.
मैंने डबल कोटेशन क्यों दिया?
But if you don't practice, that is the objective of this training, okay, hands-on training.
If you are giving this double percentage mark, it is separating the script into segments. So it will run only particular segment. It won't run the whole script, right? Please don't give double percentage mark. It will separate your scripts. Do not give double percentage mark. For commenting, use only single percentage. Double percentage will split your script into segments, so if you are running it, it won't run the whole script.
Now what next? Once we extract the stream network, we filter a channel, okay, of our interest. Okay, so same thing we'll do here. From this entire stream network, we'll select one particular channel. Okay. So to do that, right here, select a channel of our interest for slope area analysis. Select a channel of our interest for slope area analysis. Flow path. And then we use the flow path app available in Topo Toolbox. The input to this function is flow direction, DM, and stream network. Okay, now run the code. So this would open a new screen and will ask you to select a stream by defining its head, the way you have done in RGS. First you define a head and then you extracted a channel. Okay, the same thing you have to do here. Okay, you go anywhere in the landscape and select a channel head. For example, we want to select a head where my cursor is. You see my cursor. So I just simply left click and define the head there. Okay. So the thick black line that you see, that is the flow path. Okay. And in the lower panel you see the distance elevation plot. Okay, let's make it bigger. You see the longitudinal profile of this channel, okay, where the horizontal axis is the distance and the vertical axis is elevation. Okay, in class several times I draw similar figure. Okay, so this is the longitudinal profile. Okay, now once you select the stream, you have to save it and send it to the MATLAB. Okay, now to do that, go to export and then export stream object to workplace. Means we have to send this stream to the MATLAB workplace. Okay, so to do that, go to export and then export stream object to workspace, and then select name, define a name for this channel. Example, this should be our, let's say, stream 1, S1. And then hit OK.
So what was the command that you gave to open that flow path? So you need to use the command. You need to use the command.
So once you save, okay, you will find this S1 stream in your workspace. Okay. Now if you plot S1, you will find only that particular stream. Okay. Okay, let's save. Now we save this stream as a mat file. So save.
Alright, alright. क्या है
Okay, so when you want to save any variable as a mat file, you have to use this command save, then within parentheses, within first quote mark, what I wrote here, stream underscore mat. That means the name of my output file would be stream underscore one, and it would be saved as a .mat file. And what next? S1, that means the variable that I want to store in the stream underscore one mat file. Okay, if you want to store multiple variables, then with comma, for example, I also want to save the DM. I also want to save, let's say, flow directions and so on. Why we want to save? That means if you want to perform further analysis later, you don't have to recreate everything. You can simply load and run the analysis. Okay. Now once we extract the stream of our interest, now we do the analysis. Okay, now we perform the slope area analysis. Okay, slope area. Now when you want to load, for example, in the first step, you save the file. Now when you want to load the same thing again in MATLAB, you have to use the syntax. Okay, load string1 underscore mat s1. So please save your string1. Okay.
Sure.
Yes.
That MAT is that same file but stored for easy retrieval from the MATLAB.
Yes.
So what if we give multiple file names and save it under the same stream?
Okay. So then s1 comma dm comma flow direction and so on.
So that will become a repository.
Yes. So that stream1.mat would be your repository where all the variables are stored. Okay. Now once you save the stream, please comment out the flow path as and save this to line. Okay. Then we perform the slope area analysis. Area, we use this function called slope area. Input would be the filtered stream that we have done in previous step. Then dm, then area. Okay. Now listen. theta concavity. What is concavity? Now, what is its definition? The physical definition. The rate of change of gravity. So this theta or concavity, okay, it varies from channel to channel. Okay, in a landscape, if you have multiple channels, it may be characterized by different theta value. Okay, so if you have different theta value, you will get the different case. Okay, so you cannot compare one channel with the other. So if we fix the theta a constant value, okay, then our chi is independent of this exponent. Okay, it now simply a function of slope and area. Okay, so when we fix a theta, the fixed theta to a definite value, okay, then instead of chi s, we will call chi sn, normalized channel steepness. Okay, so now we will calculate the normalized channel steepness by defining a theta value of 0.45. Why 0.45? From our observations of natural streams all around the globe, we found that most stream concavity values vary within a narrow range between 0.4 to 0.75. Okay, and their mean value lies around 0.45. Okay. So now we define this theta reference value 0.45. Okay. To calculate the normalized channel steepness, which we can readily compare from one stream to other stream. Okay. So when your KSN is independent of theta, then it's simply a function of slope. Okay. But what is the definition of KS? This is slope normalized, area normalized channel slope. Okay. Right. That means it depends on the slope. Okay, while you have the steep slope, that will be characterized by high channel steepness, and slope depends on the rate of rock uplift. Okay, then ISF becomes a proxy for rock uplift. Okay. Okay, so that is also another mandatory input to this function, which we call the smoothing factor. So ideally, the channel should have a concave upward profile. But because of the noisy satellite elevation data, sometimes you find this kind of noise in the river profile or bump in the river profile. Okay. So to remove this bump from the river profile, we use a filtering algorithm. Okay. So we have to provide a K value to filter or smooth the river profile. Okay. So let's use a value of 100. Okay. Now how to shape this value 100? This definition is written in this script, slope area. Go to Topo toolbox, open the slope area, and there all the details are provided. Okay. Slope. Okay, sorry, I forgot to write one thing. So before 0.45, you have to write the theta. That means this 0.45 represents the value of theta. Okay. And let's not use any smoothing value here. Okay, we perform simply with our raw data without any filtering. Okay, now run the code. Okay, so this would provide you the slope area, okay, which you have done manually. Okay, and the thick black line that you see here, that is the regression line, least square regression fit through the data. Okay, now what is the chi-set? The slope of this black line. And what is theta? The y-intercept of this black line. Okay. Yeah, sorry. Theta is the slope, and y-intercept is the channel steepness. Chi-set. Now, if you just write SA, the variable name in your command window, there you will find the value of chi-set, theta, everything. Okay.
I don't understand. What are you defining as theta here?
Theta, that is the
Theta, but in these 5 parameters, theta is the one to be calculated.
Wait.
Sorry. Theta is value that we are going to find using that.
No. Yes. From the slope area analysis, you will get the actual theta for that channel. But here we are calculating the normalized channel stiffness by fixing the value of theta to 0.45. Okay.
So in your version of MATLAB, the algebra functions are also separated. That you have to search linear sum.
So if you just write the variable name in your command window, there you will get the theta, chi-set value. Okay. So now I request all of you to reinstall the MATLAB and make sure all the toolboxes are properly installed. Then please practice everything what we have done in the class. Okay. If you face any problem, please come back to me or to Swagat, okay, and resolve your problem. Okay. But don't tell next class that sir I am still lagging. Okay, I couldn't finish this. This should be your task to complete the things that you have done today. So today we have done using one example. Okay, but your task would be to perform the analysis on multiple streams from the study area. Okay, and prepare an Excel sheet. Channel number and their by-step value. Okay, perform the analysis 1, 2, 3, 4, 5, so on. Okay, and then write their by-step value in an Excel sheet.
The save function is not working.
Which one is not functioning?
The save. I'm not able to save it.
Okay, go to save. That means extract stream network. Export. Okay. Okay. Yeah. Close everything. Close this. And then go to your command window, save. Yes.
Then also I have to retrieve it.
Okay. Now load. Okay.
Then again I have to run this code.
Yes, once when you now run next time, and if you want to analyze the same thing, then you don't need the topo tool. Okay?
So how do I run these two plots different cases? Because the error is just coming in. Like after this the error comes, then I have to run this. How do I do that?
Think logical. Think logical. You already have some basics of programming there. If when I extract one variable and then if I want to save and again re-extract, what should be my logic? Tell me this logic. This is the basics of any programming language. What should be the logic? When I use the flowpath app, and then extract the string from the flowpath app, immediately I save it. Okay? As a MATLAB file. Now my further analysis will be based on this string. Okay? Then in the MATLAB wrapper function, I will simply comment out this flowpath app. Okay. Then I will simply load the S1 function and then run the wrapper string. Then it will simply bypass this step. Okay. Or first you extract all channels one by one using flowpath app and then perform the analysis. Okay. You got the logic? Yes. For example, let's say from the landscape I am interested to analyze 100 streams. So using the flowpath app, first I select 1 to 100 streams and store them as a MATLAB file. And then I call each of these streams one by one, okay, using the load command. Okay. So please do that and complete this exercise, okay? Yes. So you have to calculate the normalized channel stiffness and that you have to save as the Excel file. Okay, channel number versus normalized channel. And I give one number 100. Okay. But if someone is really motivated students, he will go beyond this and instead of 100, he will do 200 or 500. So it depends on the interest of the student. Okay. But MATLAB you don't get highly motivated students. Okay, the 100,000. See out of 20 students, how many of you are present here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Only 50% students. Okay. So that is the bitter part of our system. I'm spending my time and effort for you. Okay. I'm here on even weekend. Okay. It's only for you. Okay, so could you please check how many students are waiting outside? If you possible, if the number is hey, what is the problem?
Sir, I'm commenting meeting and trying to
Okay, do it.
my students.
Huh? Okay, call them. Okay, so those who have MATLAB issues, maybe I'll be here for another till 1. Okay, maybe you go to CC or somewhere and try to reinstall and come back. Okay. Yes. Static goes, okay, see, when you start installing the MATLAB, a screen will come where it will ask you the which block you want to install. Okay, please select it. So please make sure you have at least statistical analysis and solution of the simple blocks.
I have plotted the previous from the RGIS. Is it correct? Because the concavity is too low. Sir,
Yeah, tell me what's your question?
here the concavity is too low.
Yes. Why? Because you do not have any trend in your data. Okay. Look. Why?
There are
Because
some
we haven't applied any filtering algorithm. Okay. It's just the raw data extracted from the DM in digital illusion model. Okay.
in my
But in
data.
MATLAB, okay, we wrote several filtering algorithms. Okay, that is why you see the proper trend. Okay, so this exercise was just to expose you with all the algorithms. Okay,
Sir, in our data there are some values like 0, minus, these were unfiltered. Then I filtered out the 0 and the minus 1 using MATLAB. Then it is coming like this.
because you still have more noise in the data. Okay, go through the slow page of the MATLAB script, you will find all the filtering algorithm that used in the script. Okay. Swagat, could you please now let this? Okay. Aditya, the MATLAB you are install for practice करके if you face any problem please come to